Good afternoon, folks. Just getting the chat set up here. Okay. And we've got the PowerPoint. Everything's ready to go. All right. So, last time in class, I had talked about how we were going to be moving on to logical operators, which allow you to solve more represent more complex conditions. And I also talked about how programming is based on programming is building software that communicates to the hardware, which is basically logical circuitry. And so we took a look at what we can do, or we're going to take a deeper look at what we can do in JavaScript, specifically to represent some more complicated conditions, and at the same time take a look at what's actually happening in the background. Okay. And as always, if you have questions, just post them right in the chat, and I can get those answered. If you have questions on any of the assignments, this is the perfect time to ask, because I can go ahead and just demonstrate, whatever part is confusing to you, and that you'll know exactly what you need to do. Okay, so chapter 7. Okay, we don't need that. We need to know what the assignment. Let's focus on what the assignment is going to be asking you, and make sure that I didn't schedule it too early. So we have chapter 6 isn't due until November 5th, so you guys got time on that. Yeah, chapter 6, November 5th, and we just finished that. So you got a couple there, November 5th, November 12th, while we start on this chapter 7. Okay. So, if you remember, what was the first chapter where we started talking about conditions, or equality, or comparison operators? When did we start to need those? And why would we need those? So I'm talking about, two equal signs in JavaScript is equals, greater than and less than. Whatever evaluates to either true or false. That is a conditional expression. And so this chapter is talking about how do we create more complicated conditional expressions to represent very specific cases, and how to do so concisely and efficiently and with good code hygiene, which means how can we do it so that it's readable by ourselves and others, because you folks probably know you can do a lot. You can solve these problems in a million different ways, and some are more efficient than others, and some are easier to read than others, and so why wouldn't you want to do it the best way? Okay. And I'm looking for Replit, so we can see some live examples as we go through, because this stuff can it can be difficult to read if you have never seen it before. And we'll go with chapter 7, complex conditions demo. And I'll go ahead and share this in the chat if you want to check it out later, or if you want to follow along. So remember, when you click that link, what it's going to do is open my project at whatever stage it's at when you click it. So if you click it now, it's going to be a blank one, and then if you want to see where I've gotten to, you have to go back and click the link again. If you make any change, you can definitely make changes and try things out while we're doing this. It will copy it into your account, and it will no longer be able to get any of the updates that I make, but you can just click on the link at any time to get to that. Okay. So let's take a look. And so it was if statements where we really started to see conditions. All right, if true, console.log, hello. Okay. This isn't much of a condition if it's just a literal true or false value. It's always going to be true, so we can make it more complicated. So we could say num greater than 10. And we can't use the variable num unless we've declared it, so let's do that. Let num equal 12. Okay. So it says hello, and then if I set num to 9, it doesn't say hello. Okay. And then we looked at else. So we'll say if else. So if it's 9 and we're checking if it's greater than 10, it's going to do the else, run the else code. If it's 45, it's going to run the if code here. What we're focused on is this little box or area here. This is a conditional expression, and looking at this, the thing that tells me it's a conditional expression is it has a comparison operator here. Now there are other things you can use. There are comparison methods, or basically any method or function that returns a true or false value. All right. I don't think we've seen any of those so far, and we haven't gotten to functions yet, I believe. Is that the next chapter? Hopefully, because without functions, yeah, okay, good. That's the next chapter. Without functions, code gets very messy and long, which you guys have probably noticed. Okay. So, moving on with chapter 7, we have some examples of complex conditions. This will be good to put it in context. So what about someone that needs to have 12 credit hours and a GPA greater than 3.5, which I believe coincidentally is the same requirement you need to do an honors course. It might be 3.0 GPA. Anyway, to do honors, like an honors project in a course, which I do offer in my later courses. And you can do the projects whether or not you are eligible for the honors credit. But if you are, you can get some extra credit there. Here's another one. If you're under 6 years old or over 65 years, so, see what you can notice that's in common between these statements here. Employee bonus vacation. If you have the sales quota and no absences in 3 months, then you probably get some sort of bonus vacation. And so take a look at these 3 phrases here. These are still fairly simple conditions, but they're complex because they involve multiple sources of information. And in some cases, you only need one of the conditions to be true, and in some cases, you need both. So the word in here that lets us know this is using some logic that translates into Java that we can create in JavaScript. Oh, good question, Wyatt. Yes, extra credit means, in this case, on your transcript, it'll show you that you completed the course with honors. If you complete enough hours of honors, you graduate with honors. So it's just a little bonus on your transcript, which may or may not help you depending on the industry. It doesn't hurt to do it, in my opinion. If you aren't doing your own personal projects outside of the classes, this is a good excuse to get something out of it, other than what's really valuable is the experience and the knowledge of doing it. But some people want, some kind of proof that they did it, and that's totally fine. So, basically all of my honors projects and courses are, hey, here's this tertiary technology, or this technology that we don't have time to talk about in class. How about you teach it to yourself with my guidance and build something using it? And they're almost never the same from semester to semester. It's usually whatever has piqued my interest, but I have not had time to explore myself, so I have you guys explore it so you learn, and then I can in turn see examples of, you can tell me what examples you used that were good to help you figure it out, and then I use those as honors projects ideas later, or whatever, introduce a new class because some topic is important. It's an awesome win-win situation for everyone. It helps you get more experience. It helps me get more material, because everything's changing. It's like, how Uber, you're doing ride sharing or whatever. This is like knowledge sharing. Okay. And if you have additional questions about that, feel free to ask them now, Wyatt. It's totally fine. If you want, if you have a question you'd rather ask through email, definitely ask me, and I can give you even more specific details about any of that, like some example projects from previous courses. Okay. In most of your classes, you can just ask the teacher, hey, are you doing honors in here? Because I'm interested and I have the required GPA and semester hours. And then they'll let you know, hey, okay, I do have something, or no. All of my courses I would be willing to do honors, because it's not that much work for me, and it helps you immensely. Okay. You get a lot more for your money if you do it. Okay. Boolean variables. We've already talked about these. There's two values in Boolean data that ultimately boil down to true and false. Let x equals true, and you'll notice the word is blue to help us identify that it's a keyword, which means we can't say let true equal hello. Let's see if in JavaScript it cares about this. It should. So you can't use keywords, obviously, as variable names. So this is it's a reserved word by the programming language. So we can't do that, but we can store these values. So in this case, x would have a data type of Boolean, y would have a data type of Boolean, because there's only two values, true and false. All right, that's all. And any questions on that, go ahead and ask. But it's probably the simplest, thing, though it has such a fancy name. When you're learning a subject like this, every time you encounter a word that you've never seen before, especially if it's long, it can be scary. But I just want to tell you, this is just a very fancy word for on or off, true or false. Okay. These are new for this class anyway, and they are extremely useful. They are the logical operators. They are known as and, or, and not. Okay? So if we go back to these examples here, it said, to be on the dean's list, you need 12 credit hours completed and a GPA of greater than 3.5. So does that mean I can be on the dean's list if I've completed 12 credit hours, but maybe I don't have a GPA of greater than 3.5? No, we have to have both. And why do we have to have both? Because they put the word and. So this will only be true, I'll only get on the dean's list in this case if I have 12 credit hours completed and the right GPA. If one of those is missing, I won't be considered for the dean's list. Okay? And we have the opposite down here. To be able to get the movie theater discount, you have to be under 6 years old or over 65. Now, if they put the word and here, how many people would ever be able to get the discount? You have to be under 6 years old and over 65. That's going to be challenging. Not a lot of people are going to get that discount. So the word or here means only one has to be true to get the discount. And then down here it's and, which means we both have to be true. Okay, so understanding and or is extremely important here because it allows us to control very specific conditions. And you can think of your own examples. When I was in grad school, the example I remember the most is, it's raining out, or like when would you bring an umbrella? And then one of the conditions was whether or not it was raining out, and I'm realizing now I don't remember the rest, so it's probably a bad example. So, but these examples are good. I always struggle to remember these, so I'll have to remember this is here. Okay. It's hard to think of them on the spot, and I almost do everything on the spot here, so. Keeps me sharp. The other one here is not. It says use to negate a condition. It just changes true to false or false to true. It just does the opposite. So I can say, for example, back in these examples, if you are under 6 years old or over 65 years old, you get the discount. Or I could say, if you're over 6 years old and younger than 65, you don't get the discount. So I could say, check those conditions and then use the not operator to convert it to what I need. Now, why would you do that? That again was a bad example because when you start using double negatives in your code, it gets even more confusing. And when you combine stuff like that with and or, because you can use both in a condition, you can have multiple ands, multiple ors. It follows a operator precedence. So like, in math, parentheses, exponents, multiplication, division, addition, subtraction. Well, and or also has a operator precedence. So, if we add 1 plus 2 times 5, it's not 15, it's going to be 11 because you take the 2 times 5 first to get 10 and add 1. With and or, you have to do all the correct calculations on whichever operator has precedence before you do any operators that have lower precedence. And sometimes you have to use parentheses to break those or to control the precedence. Okay, just in case, by precedence I mean the order that they're completed in. So with math, you always do everything in parentheses first, yada yada. Oh, very good example, Wyatt. So you have an if statement that is checking if they've typed stop in the input. Okay. Let's do this because this is actually a really good example, and I want to show if this helps. Let's go let answer equal prompt. And what am I doing there? If I do that, I am asking the person for some input. And I already forgot what Wyatt said. He said, oh yeah, stopping. So stop or continue. And so we're saying, okay, if answer equals stop, and then Wyatt said, well, what if they capitalize stop? We can do or answer equals stop with a capital S. So if they type stop lowercase or stop uppercase, it will, okay, I'll stop. Or if they don't type that, they'll say, I'm still going. All right, I might have forgot something here. Okay, stop or continue. So if I don't put stop, it says I'm still going. If I put stop lowercase, okay, I'll stop. And then stop uppercase, okay, I'll stop. But what if they type every other letter uppercase and lowercase? Now, you know, who is going to do that? Well, someone will. So how would we fix that? There's a little programming trick here for dealing with user input that basically strips out whether or not, basically it makes lowercase and uppercase the same. Hey, Alex. Okay. So in this case, you know, you've got the right idea, Wyatt. This works for those two conditions, but maybe we want to cover a much broader set of conditions easily. This is a good example of using or. Okay. What we can do is, and I'm not even sure if this has been mentioned in the book or the notes. Oh, here we go. I haven't got this far in the PowerPoints yet, Alex, so I will cover it, but this means it's the logical OR operator, and the vertical bars on the keyboard, this is for everyone, the vertical bars on the keyboard are above the Enter key. Okay, you hold Shift and hit backslash, and that gives you the vertical bar. In JavaScript, two vertical bars mean OR. Okay. And since you mentioned this, why I just want to show you this little shortcut. All right, there is a method of strings in JavaScript that allows you to convert the entire string to lowercase. And so if we do that right before we check the value, it won't matter how they capitalize it, it'll work. So if we do, and then we don't need the OR operator here in this case. What we can do is if answer dot to lowercase equals stop, it should work in every case if I have the syntax right. Okay, so if I do stop lowercase, that works. And if I do stop uppercase, it still works. And if I do every other level, every other letter, not letter, level, like so, it'll still work. So this is a little trick for you in dealing with user input if you're worried about capitalization. Or basically, if you don't want input to be case sensitive, you can just use something like this. All right. So we're focusing on and or. The not operator, let's talk about that real quick. It's probably the simplest one here, but it can make things very complicated when you're using it with and or. Basically, you know, if so, very good point, Wyatt. So here, when we're asking them the question, we're storing their input in answer, and then here, where we're using the to lowercase, it's actually not changing the value of the variable. It is just converting it here temporarily to create the value as all lowercase, and then if you use answer here, it should retain its original entry. So if I do STOP and do every other one, it will just use the lowercase to do the test, but we can still capture what they actually typed. And you could, you know, why would you do that anyway? I mean, in this case, it's probably hard to think of a reason, but there are reasons you want to collect it. And even maybe for a reason like this, if you are collecting the user input as a way to test for, you know, how many people actually type it lowercase, how many people type it uppercase, and maybe you could use that information to make the input better. So yeah, hopefully that that makes sense. Yeah, in this case, you know, you don't need to overcomplicate it like I'm trying to talk about all the things. Mailman's here. Okay. So we can print out. You can print out Boolean variables. We'll do console.log x. And we'll do it this way. X is that, and y is y. Okay, this is going to be exciting, right? And we'll just turn off this code up here since we're done with it. Okay, we assigned x the value of true, printed it out, x is true. Really exciting stuff, right? But what if we do this? And we can say, okay, x is not, and y is not. Oops, forgot a space. So it says x is not false. So this is saying, you know, this is the not operator. This is not x, which means whatever Boolean value it has, it's going to change it to the opposite. And again, just like before with the, you know, changing the string to lowercase, this is something that I've probably taken for granted for a really long time when I'm teaching this. Whenever you do something like this, unless you're using an assignment operator, you're never changing the original value. So you know you're not changing the original value if you don't see the assignment operator, which is 1 equals sign. There are methods, though. Rare. Sometimes they're rare. It just depends on the language. And basically, if you're using a method that is converting one thing to another, most of the time it should return and become, from the expression, whatever that converted thing is. And then if you want to store it, you can. If not, it doesn't ruin anything. But there are methods that will change the original value. Okay, and that's more important in like object-oriented programming, which you can do in JavaScript, but we won't be doing in this class. Okay. So is the not operator, that makes pretty good sense, I think, right? If it's not there, it's going to say what it is. If it is there, it'll say the opposite. Okay, that's the not operator. So we're just printing out the value of x and the value of y here. So since we set x to true, it should print out true here. So it should say x is, well, we had x is true before, but here we're saying x is not because we have the exclamation point as the not operator. So since x is true, x is not false. So x not, or not x, since it was true, it outputs false here. Is that confusing? Listening to myself right now, it sounds really confusing. So let me change it back one more time. Well, actually, instead of changing it, why don't I just do this? Let's have both. That way you can see it at the same time and it'll probably be less confusing. I'm glad, I am always proud of myself when I think of those things. Okay, so x is true, y is false. We were just changing it for the meaning, not the grammar, right? So x is true, y is false. We know that because that's what we said it that way. Oh, don't worry, Alex. Definitely ask questions. Even if, you know, it may be hard to focus sometimes, and still ask questions. I'm more than happy to explain it. And, you know, the only people that show up to these live streams are the people that are interested and usually already can, you know, I don't even need to talk to you. You could probably just read it and figure this out. But for the people that watch it later, or, you know, in a month are like, uh-oh, I didn't do anything. Can you help me catch up? I'll say, watch the videos. And they're the kind of people that will need me to do it, you know, 3 times or show things like this. So it's not a waste of time. Okay. Whew. So this is the key here that I'm trying to show off, is the not operator. And you can even use it in conditions. If x is not equal to y, we can say x and y are not equal. Okay. X and y are not equal. What do you think this expression evaluates true, and how do you know? So it starts like this. It's just like in math when you show your work. When you evaluate an expression, you do the same thing. That's what, you know, breaking down an expression into something simpler, you're simplifying the expression. If you have equalities, you can solve for, you know, whatever you want, and you'll have the formula for it on the other side. In this case, we have all the values. We just have to plug them in. This becomes x, well, x is true and not equals false. And you can evaluate this just like an expression. Is this true or false? We'll change this too. So is true not equal to false? Is that true or false? And that's why reading this out, it sounds really confusing. So true is not equal to false. So this expression is true. Is that confusing enough for you? Because true is not equal to false, this conditional expression will evaluate to true, which means it will run this code, even though it's dependent on them not being equal to be true. Does that make sense? All right. in Python, the logical operators use the words and and or, and so you can read it much better. But so I feel like it's helpful to actually translate it into English, an even higher level that we can understand. And then when we're writing it like this is the highest form that the computer can understand in terms of JavaScript. It doesn't know what the word, it doesn't know what this phrase means. If we want to ask this, it needs this. So bringing it up to a high level that we can understand so that we can translate it down to a low enough level that the computer can understand is our job. That's why we get paid the big bucks, because we are just computer translators, basically. And at the same time, we're also critical problem solvers, because the people that want us to solve problems have no idea how a computer works. So it's also our job to discover a way. That's why we talk about software as a solution. There's no reason to make a program or do programming if you're not solving something. So it's always a solution. Whether it's, to make someone less bored or to entertain yourself, there's always a problem that you're trying to solve. Some are better than others. Some people are willing to pay you to solve. Okay. And so if you do this job, you should feel very useful to society, because you are making everyone's life more efficient and easier. Okay. Going back to where we were, and or and not. Okay, so I think they have some examples in here. This is pseudocode, yada yada. So basically I'm showing you in the comments as we do this, the pseudocode, because that's how you should imagine it in your mind. You'll see me when I'm writing code, putting the parts in that I know are the same in every programming language while I, scan my memory for the correct syntax. And then if I don't pull it up immediately, I just Google it, because I know exactly what I'm trying to do, and I know a computer can do it. I just have to remember how to tell it to do that. And, I don't use all of these programming languages every day. I only use them, 6 months, for sure, 6 months out of the year, or no, I'm sorry, however many months, 16 weeks, that's what I'm thinking of. 16 weeks out of the year for one class, so, one time a week in this case. So it's a useless task for me to memorize the syntax, but if I got a job using JavaScript, very quickly I would memorize the syntax, and so would you. Just like we live in the US, so it's actually hard not to learn English, right? And if you try to move to a foreign country, you're going to pick up whatever language they use, because you'll be exposed to it every single day. Okay. All this is translating from English to computerese. Okay. Or versus and. We talked about that a little bit. And allows you to create a situation where you need all of the conditions to be true, or allows us to have conditions so that only one needs to be true. And it works the other way around. So, true is going to be false if anything is false, or can only be false when everything is false. Okay. And the not operator, just talked about that. Okay, I think once you understand the not, they're showing here, once you understand the not operator, it's tempting to use it all the time, but it just if you're not using it properly, it can just over complicate things. So here, if we want to know if something is greater than 200, we should say if it's greater than 200, not if it's not greater, or not if it's not less than 200. That is just overly obtuse and complicated. So you kind of have a responsibility now that you know that exists to understand when and where to use it. And for this class, it'll just tell you, right, when to use it. Okay. But I'm glad that it's telling you when not to use it. Okay. So let's take a look at some. We have x and y up here, true and false. So we can just try some of these out. If x and y, or actually, instead of using it in an if statement, we'll just print out what it actually becomes. Console.log. Let's use the expressions. X and y. So the operator to the computer for and is 2 ampersands. It looks like they only have the pseudocode in here. Anyway, you'll just have to take my word for it for now. It's probably in there later. So let's print out x and y. And that prints out to false. X and y evaluates to false. Even though x is true and y is false, with and we have to do both. Okay, so let's put a little note in here. X and y. So we can say, okay, what did I forget here? I might have to do this. It might be considering that string there a true, since it has some value in it. Let's see if it breaks. So in this case, we had to put parentheses in so that it evaluates correctly. So, I'm always encountering little things like this that, I would be able to figure out in a few seconds, but if you don't know what you're doing, it can really make it harder to learn. So let me recreate what was happening here so you can understand how I fixed it. Okay, so here we have a string literal. Okay, that's what this is called. It's a string value. It's not a variable. Here we have a variable that is of data type Boolean. Here's another one. And we have the AND operator, and this is, we're trying to use it as the concatenation operator, which combines two strings. It's also the addition operator, which I believe it was using this to say true. Since this was Boolean and this was string, it's probably trying to say this plus x is true. Well, we can know for sure. Let's just print out what that is. So you can always use this not only for debugging, print out what see what the computer thinks it is, and then when you know for sure, you can kind of identify, well, that's not what I meant it to be. How can I change it? So here, if we print this out, it prints out x and y true. So it is just concatenating on the word true, it looks like. Okay. And so here we have the string x and y and the word true, so that'll be the string there. So it is concatenating it. It's converting the Boolean value to a string and concatenating it. And then when you take that and you do the AND operator here. Let's see what that does. So let's do let's take 1 for example here, and we'll print out, instead of printing out this string, we want to print out the string and the value of x. So this one is and. Okay. And it looks like it didn't print out the word and. It actually printed out the word true. What does that tell us about the AND operator? It actually tells us more about strings. If the result of this is true, and we know x is true, so by deduction of how does this turn into true, if it's and, what do we know? That means both sides have to be true. We know x is true. Maybe we don't know whether this string is true or false, but based on what it's showing us, what do you think it sees the string as? True or false? And you know because what it printed out here is true. So, you know, I'm confident in saying at least this string evaluates to true, and probably any string with any value in it is true, but let's see if the empty string may be different. Oh, in that case, it just didn't print anything. That's weird. So I'm wondering if that became a null value, or if you... Anyway, this is getting in the weeds. But here's the thing. You need to know how to get into the weeds and how to get yourself back out. So that's what we're doing right now is... Oh, this is... You're going to encounter a ton of things that aren't working the way you think they should. And you have to be able to accept that you may have been wrong, because... You know, in this field, we really like to, you know, figure things out on our own. But if you're just staring at this, trying to think of a reason, you know, that's a good starting point. But don't spend too much time on that, knowing that there's ways you can get more information to help you figure out what's going on, which is hard to remember. Kind of like if your computer, basically anything electronic, is not working the way it should, you know, turn it off and turn it back on again is usually going to fix it, and it takes almost no time. But even though I know that, I still try to figure out the problem on my own, or forget to do the most basic troubleshooting fix, which is turning it off and turning it back on again. That'll fix 90% of the issues you have, slow down, things aren't working. It's even as simple as whenever my webcam stops working for this stream, I usually just have to deactivate it and reactivate it. And I know how to do that in the software. If I didn't, I could probably just unplug it and plug it back in, or close and reopen the software. There's all kinds of, you know, it's all the same thing, turning it off and turning it back on again. Okay. Let's look at OR. So anyway, I don't want to get any more into this right now, because you're not going to need it for this. We want to know how the AND operator works. Okay, and the reason we were looking at this is because of order of operations. We want to, depending on whether this plus sign operator has higher precedence than the AND, it's going to determine whether or not this results in a Boolean value or a string. And so remember when we just did it this way, it just printed out false. So we know there was this string here and that didn't get included in this. So it's turning into a Boolean value, which leads me to believe it does this concatenation first, then it does this combination. But how do we know? We can look up JavaScript operator precedence. And again, when you use this stuff on a daily basis, this will be like second nature to you. So yep, good example. Infinite loops are definitely much easier to fix if you just kill whatever is doing the loop and then start it over after you fix it. All right, precedence. There are a lot more operators in programming, actually, just even in mathematics, than most people are aware of. So the programming ones are the ones we care about. So there should be, here it is, the master list. Highest precedence to lowest. And so we can ignore anything we don't need. Grouping. So parentheses, still top of the list, highest precedence. You can use that to control the precedence in the way that you intend. All right. Member access is left to right. So when I do console.log, it looks in the console for a log method. All right. It doesn't look for a log method and then use console. That one isn't that important. What were we looking for? We were looking for concatenation. So let's find that. I'm not sure if they would separate that. It might just be considered the same as addition, but there's a way we can test that too. Okay. Addition is precedence 14 right after multiplication, division, and remainder, the modulus operator. Okay, and I'm wondering if they have concatenation in here, if they just call it addition. Okay, anyway, if they don't have it in there, it's probably because my understanding of what it does not match what they're explaining. So let's test it out. Let's have console.log. We need a string, and we want to concatenate that with the addition of 1 plus 2. So we wanted to say hello 3. Let's see what it does. It says hello 12. What if I do, maybe I wanted to say 12 hello, 3 hello. So I want to add 1 and 2 together and then concatenate that with the word hello. Okay, now it says 3 hello, but if I put it, now I want it to say hello 3, it doesn't. It says hello 12. What is happening? Anyone have a guess? This tells me that concatenation and addition have the same precedence, so it falls back to what we talked about earlier, left to right, which some people do all their math from left to right, and that's why, things don't always work because they don't know operator precedence and order of operations. So you do need to know that, and it gets more complicated when you start calling methods inside of other methods and things like that. You have to be able to read it and quickly track where things are coming from, but we're still here in the beginning and we're just working on that. We're starting to work on that. So why is this 12? Well, because it starts with a string, and it's going from left to right, it says, okay, add this value with this value. The first one's a string, so let's convert the second one to a string so that they can be added together. Because you can't convert hello into an int, probably. And then once that's done, and this is the perfect time to take a look at how this expression evaluates. So it would add 1 to hello first in the first step, and then in the next step it would put the 2 on the end, like that. So it does the first addition on the left, then it does the next leftmost one. Does that make sense how it does that? And remember, everything that the computer is doing, there's nothing magic going on here. It's just we may not understand, and understanding will help us be more efficient. So how do we fix it so that it says hello 3? Does anyone have a guess? Simple change we can do here. I mean, I guess I already showed you guys. All we have to do is control the order of precedence by adding parentheses, because those are the innermost parentheses are going to be processed first. Okay, and that'll give us hello 3, because this one will evaluate this way. If this is a topic that is confusing you, this is one of the most basic fundamental principles of math, and so if you learn this, it'll help you in math immensely, and it will help you in programming. And it is a foundational piece of knowledge that, unfortunately, a lot of people are missing. And so if you are struggling with this, definitely talk to me, and we need to get you to understand this. Okay, so anyway, this will evaluate to hello, the string, plus 3. Because we have to do what's in the parentheses first here. That supersedes the leftmost thing here. So does 1 plus 2. Well, those are both ints. That makes 3. Then it will do the next step leftmost, which is just hello plus 3. One of them is a string. It will concatenate that into hello 3. And this, what we're doing right now, this is what a logic course should be teaching you. Alright? We don't care about building a chair right now. We are worried about how do we prepare the wood for the chair so people don't get splinters. Okay. Plus, how do we use it? What tools are there to even use to do this? So that way you're not trying to use, a chainsaw to build a chair. Which people do that, and that's fine. But if you easily want to make a chair, there's a much easier way than learning how to use a chainsaw solely. All right, which is like trying to write all your code procedurally. That's like taking a chainsaw to it. For little things, hey, I'm not, I'll chainsaw a log in half or a board if I just need it quickly, and it's going to be thrown away after that. Or if it breaks, I don't care. But if it is something complicated and with a lot of detail, it's going to be hard to do that with a chainsaw. Anyway, I'm really enjoying this chainsaw metaphor. Okay. And then JavaScript is like a gas-powered chainsaw, and Python is like an electric battery-powered chainsaw. Okay. Yes, C++ is a diesel powered bulldozer with a giant chainsaw where the scoop should be. I think it's called a scoop, maybe. And it's also held together by duct tape and paper clips, and you have the ability to reorganize the duct tape and paper clips at will. Actually, you have to. It won't work if you don't adjust those paper clips. Okay. Anyway. And then a language like COBOL, that is, you have a sharp stone. And so your hands are going to be very hurt after you build anything with a sharp stone in place of a chainsaw. Or better tools like, a table with a saw built in, or common. Okay. Are you guys done with the saw metaphors yet? Okay. I love metaphors and analogies. It's probably more accurate to call it an analogy, but this isn't an English class, so I'm going to stop pretending I know anything about that. Oh, thank you, Wyatt. I wish I had a bulldozer. Okay. So it's called a blade. You learn something every day. Always be willing to learn. All right. Also, be willing to remember what you're talking about. Okay. Anyway, order of operations. This is how we fixed it. If we wanted Hello 3, why do I want that? Well, it doesn't matter. You need to learn how to tell the computer what to do to get anything you want from it, because it is subservient to you in every way possible. Now the metaphors are getting weird. Okay. Let's use the PowerPoint. That usually keeps me on track. Oh, so this is an example of and then that got us into operator precedence. So we know the plus sign is level 14 in operator precedence, and the logical AND operator is 7 steps later. So that means addition is always going to happen before any logical operator is triggered. So up here we had x and y plus x, or I'm sorry, this string plus x, and whatever the result of that is gets ANDed with y. And so that's why it came out as x and y are not equal. Wait, no, that's up here. That's why it came out as false. We're just printing out the value of false here. If we want to print out the string, we just have to tell it to do the logical operator first by using parentheses. Okay. And remembering all of your parentheses. It likes to, in Replit, when I'm putting a parenthesis at the end, overwrite the existing one. I think it's trying to help. So here, now we can say false. That's the first one here, line 24. And this says x and y space false. That's this one here, because we changed the order of precedence. Okay. And if we look here, and happens before or. And that's very important to understand. So all your ands in the expression will go first, and then it'll go back with whatever, the expression of it evaluated to with all the ands, and go back and do all the ors. Okay. And the not operator, where the heck did that end up? That is 17, which is even before addition. So interesting that that one is up here, and the other one there, the not is before addition, and and or are after. A group of very smart people develop this based on how things actually work and truly representing it. So we don't need to know, the only reason we need to know operator precedence is because a lot of times we'll make mistakes in that while we're writing code, and if you don't know that that's even a thing, you'll never solve that problem without trial and error, which if you're using trial and error to solve problems in your code, that just means you're naive of what's available to fix it. And so in this class, we're trying to give you enough basic skills so that you can figure out everything else on your own. Because you won't understand the scope of what's possible in here. All right. So we did and, we did or. Let's talk about truth tables. So this is a way you can basically map out every combination of true and false regarding and or. So the way you read this, and is there a way I can just turn off all of these? This isn't part of it, is it? Oh, good, I can just get rid of it. It's very in the way. Okay, here, this is for and, so the way you read this is condition 1 and condition 2, here's what it evaluates to. So we already said this. These are easy to remember for the basic ones because it's logical and it's something you deal with every day. If this and this is true, that means everything is true and the result will be true. If any piece of it is false, the first condition, the second condition, both conditions, that's false. Or the opposite, if any of the conditions are true, I don't know if opposite is the actual right term for this, but you can tell, it's different. Anything's true, it's true. And they both have to be false in this case for it to be false. All right? So they organize these logical operators into something called a truth table. And here's the not truth table. This one's even simpler. If it's true and you not it, it's false. If it's false and you not it, it's true. Okay? And you can build your own truth table based on the whatever whatever expression you're writing to represent some situation involving both and or, by providing your conditions and the operators involved. So we'll just make something ridiculously complicated here. We'll say, I'm going to comment everything out before this so we can get rid of that mess. We'll bring this, we'll just leave that up there. And we'll just do this. X equals true. We're not declaring these variables again, we're just changing the value inside. And I'm only doing that so we can see it down here. So if we have print, I'm doing Java, or I'm doing Python, which is not what I want to do. I want to do console.log, which is right up here. I don't know why I had to think about it. X, that would be true, right? If we did not X, that would be false. But what about not X and Y or X? So looking at that, what do you think it's going to evaluate to? Is that going to be true or false in this case? Because we have X is true, Y is false. Okay, the fact that we only have the variable in here as X makes this a bit simpler, but when because we're only using Y and X, but if you have multiple conditions, it can be more complicated. So let's see. This evaluates to true, and we can see that because order of operations is going to do the not first. So let's put this in with the values first so we can see where it starts. So here's our condition. We have, with the values in, true, not true, and false or true. So we know the not is the first thing that happens, so this will become false and false or true. And then remember, the or happens before and, so we have to do the ors first. So this would be, we're going to wait to do this, false and whatever the result is of this. So false or true, and if you're looking ahead, go ahead and post what you think it's going to be for each piece here. So this will become false and false or true. Well, it's funny, it says false or true, which evaluates to true. And then the last one is false and true. Everything has condensed down into false and true, which is false. So this is how the computer reads. This is what I've told the computer to do is follow these steps. Change X to not X, and then or false or true, and then false and true. And so it'll ultimately, this will always become false. Wait a second. How did I end up with false and it says true? Okay. Not true. Did I read the operator precedence backwards? Oh, I did. Because I got confused by the bitwise and or, which we're going to ignore for now. Okay, so and happens before or. This is why it's important to know the order of operations. So this is false and false. That would evaluate to false. And then we move down, we just bring down the or true. Thanks, Wyatt. I'll totally say I was using that as an example of why this is important. We'll fall back on that. Nah, I'm only human here. And, you know, I feel like if I just memorized a script to read to you guys, it's going to be boring. So always be watching for me making mistakes and let me know. Okay. False or true. What is that going to evaluate to? Well, if you look ahead and cheat, it's true, but if you have either or both of the values are true in an or, it's true. So that's how we got true. So these are the steps you're telling the computer to follow to check. And so it's a lot simpler here when we're just using, you know, literal Boolean values, which you will rarely ever do. Well, I've rarely done it. Okay. Let's make some more complicated things. So let's say salary equals 6,500. We'll do 65,000. There you go. That's a pretty median software developer salary. Higher for our area, but that's okay. Everything doesn't cost an arm and a leg, so you can make that go. You can make it go pretty far where we live. All right. Let's also add an age, and we'll put a price, and we will put a name, and what about, thank you, Charlie, I really appreciate that comment. I'm worried because not a lot of people show up to these, but I understand my program is going to be rigorous, and if you guys are having finding this interesting and not boring, it's a really good sign that you're gonna be able to adopt this as a skill. You'll be able to be honed into a employee ready, job ready software developer. Okay, I do appreciate that comment. Okay. We got this is enough junk here. So let's make it more complicated. Let's say we want to know if Bob is, well, I'm just assuming all this information is the same. Now, what does price mean? Maybe we shouldn't be giving people prices. Let's change this to savings. And this really hits home, probably, well, for me and probably for a lot of you. If you are able to save money, do it. If you can even put $5 a paycheck away and just never access that, you're going to thank yourself in 10 years. Because I want to go back 10 years and slap myself for not doing it. Anyway, it's something you'll have to learn. If you don't do it now, some people just have to learn it the hard way, like me. Okay. But if you do it before you're 65, then you don't have to suffer as much. All right, we want to check some conditions here. We want to see, here we go. We'll just make another person, and then we'll do some comparisons. So let's say someone makes 80,000, and they are 26, and they have 20,000. No, let's say they have 10,000 in savings. All right, and we'll say Chad. That's a good name for. In this, so the backstory here is Bob and Chad both work at the same company. Chad has higher education, and so he was able to get a position above Bob, and he's younger, and he has more money. And Bob did not properly save. Anyway, he's not a fan of Chad. Okay, there's your backstory. So we want to test some things here. So, let's pretend we are Facebook or Google, and we've scraped all of this information from all kinds of sources, and we want to compare the differences between Bob and Chad to better understand maybe who we should market to or target with different products. Okay? So we're looking at, hey, who should we target for a small personal loan? And maybe who should we target for a home loan? All right, so someone that needs a personal loan probably has low savings. Okay. Thank you, Wyatt. I am doing Python here. Exactly right. And I wonder, there are a lot of things in JavaScript that you don't have to do, but the reality is you are probably going to use JavaScript for some things, but you might use something called TypeScript, which is a version of JavaScript, but it requires that you type your variables. So you have to provide a type. So here, salary I would have to explicitly tell it that this is this is going to be an integer, and from then on an integer is the only value that can go in that variable. Because we're using JavaScript, I could change this to a string, a Boolean, any other data type, and that can cause problems down the road if we can't be sure what values are going to be in that variable. Okay. So I think I got what you were saying, Wyatt, but if you notice anything else. Okay, anyway, for a small personal loan, has low savings, maybe a average low salary. You know, we don't want anyone, you know, giving a loan to people that are, you know, risk of dying before they can pay back their loan. So we'll say the age has to be less than 45. And we probably won't be using the name here, but what about someone who might need a home loan? Someone who has savings for a down payment. So, you know, and then you would determine where they live. Where they live is probably, ooh, that's a good one. Let location equal, I just made this up. This is probably a real place's zip code, but I'm just gonna make one up for each of them. Okay, and I have 4 minutes left here before I have to go to my next class, so we'll just do one of these and then I'll pick up where we left off. So we learned about nested if statements. You could do this with that, right? But we could also do this with a complex condition. So we could say if we really probably should have stored, I always want to use objects, so we'll say this is okay, we'll do this using control click to put the cursor in front of all of these, so that way I only have to hit the 2 key once. Sure, you can call it lazy or you can call it efficient. Either way, I'm getting it done sooner than someone who's clicking and pushing the 2 one, you know, for each time. So in this case, it would not, since I'm rushing myself, very good questions, Wyatt. Okay, semicolon's right. In JavaScript, it will make assumptions about where your semicolons will go. So there are a lot of times you don't need them. But again, like if you end up using TypeScript, it has different rules. A lot of similar syntax. But you want to get in the habit of including those. Okay, yeah, and then the naming thing, I only just realized that. You cannot declare the same variables, names, you cannot declare them that way. Okay, so you saw that, so, okay. 2 minutes, I should really be setting up. Why don't you guys, here's a little challenge for you. Why don't you guys try to create the condition for each of these? So you're going to say if, and you can just do it for Bob first. So you come up with a condition that meets these. So they need a low amount of savings. We'll say less than 5,000. Because then we know they may have some sort of bill that's more than 5,000 that they need money for, okay? And this is, we're doing this example because this is kind of relevant to things right now. And is this ethical? Is it ethical for companies that can scrape our data? Perfect. Whoops. Awesome. Thank you. That would have been confusing. But anyway, companies can scrape our data and build a profile about us to target ads at us. And it's good in some ways because you won't get ads that are junk. But at the same time, you may be vulnerable to... They're detecting vulnerabilities in people, and so they can target them with products that may not actually be helpful to them. Like if you have, if you have a ton of debt and someone is offering you a small loan, you should probably really think about that instead of it being, a quick fix. So, is it ethical to do this? That's up to you. I don't think it is in this case, because I know a lot of people don't have the knowledge to know that they should and the resources to know. So anyway, okay, small personal loan criteria. It's 2:30 now, so let me just, okay. Is anyone in here in my database class? Sorry about that. Okay, has low savings, so less than 5,000, an average to low salary, we'll say less than, man, Bob should not be mad if someone else has a higher salary than him. If he lives in this area and he has that salary, he should be quite comfortable. Okay, less than, I'm going to change that to something so we can see that. Okay, 45,000, we'll go less than 50,000. And so feel free to try to do this as nested, but what I'm trying to get you to do is to build the complex thing in here. So we'll have to see where to use your ands and ors, what comparison operators do you use, what order should you put it in. So you can plug in Bob's information versus Chad's information and see a difference here, and then we'll talk about this one next time. So thank you guys. Email me if you're stuck on anything, and I will see you in the video next Monday unless you schedule something earlier. If you haven't done advising yet, make sure you email me and we'll set up a meeting. Otherwise, I will see you Monday. All right. Thank you, folks. Have a good day.